Servus and hello everybody. I'm Thomas, the developer of the InEL IR-Cam. InEL is a small company in the beautiful Tyrol, which develops electronics, primarily for industrial and automotive applications. But we now combine work with our hobby, FPV. With InEL IR-Cam, you're not only getting a thermal FPV camera, you get a mixed thermal FPV solution. Low latency of the visual camera in combination with the thermal view to find anything, anywhere. All controlled by your radio. A package full of features to detect thermal hotspots for a reasonable price. In this video I want to show you all the features of the InEL IR-Cam and how you can integrate it into your FPV setup. Let's switch to the desk. The InEL IR-Cam can be easily integrated in several FPV builds. For example, on this 6-inch setup, it uses 4S lithium-ion batteries and is designed for long flight time, GPS navigation and autonomous flight. You can see the stack, which consists of an ESC, flight controller and the IR-Cam base. The IR-Cam module can be seen at the front. Higher standoffs are used. On top is the servo motor connected with a flexible arm. Due to its small size, it even fits into 3-inch quads. Here we use an all-in-one flight controller and a 3S battery. The IR-Cam weighs only 27.7 gram. The servo adds another 11.2 gram. But all in all, it's possible to stay beneath 250 gram, even with our awesome antlers. Nevertheless, the 3-inch quad is equipped with the 1-axis gimbal, GPS and buzzer. It is compatible with Betaflight and iNav. The key feature is the combination of the visible and thermal image in real time. It's not only overlaid, it can be also merged with the visible image by choosing a transparency. Only specific temperature ranges can be displayed using selectable settings. The resolution and frame rate of small thermal sensors is too low to orient oneself with a FPV drone without restraints. In combination with the visible analog FPV camera, you would have a low latency and a huge field of view. To achieve this, the data is processed with a powerful FPGA. This leads to an additional latency of the visible video stream smaller than 0.1 milliseconds. This combination allows pilots to fly accurately and detect thermal hotspots despite the limitations of the sensor. The InEL IR-Cam can be fully integrated into FPV builds. It can be powered with 2S up to 6S batteries. One big advantage of analog video beside costs is the possibility of using multiple goggles and monitors simultaneously. To control the settings with the radio, a flight controller can be connected via the serial protocol MSP. This allows you to switch between various modes and adjust parameters live during flight. It can be also used for firmware updates. All information you need is displayed. The FC connection state, current profile and the count of enabled profiles, the profile name, and next to the profile name, the active adjustable parameters are shown in the brackets. There are 5 adjustable parameters: transparency, temperature threshold, minimum and maximum temperature, and the servo position. On the right side, a color bar and the current values of the parameters are displayed. The current servo state is represented with a lock. The thermal sensor calibrates itself with a shutter after a while. During this time, no thermal image is available. When using the radio, the internal channels can be chosen freely. In my case, I have a toggle switch to switch between different thermal profiles and 2 potentiometers to adjust different settings. Alternatively, a keyboard can be used for inputs. There are several automatisms available which adjust the parameters value automatically depending on the situation. For example, the auto threshold sets the threshold temperature, so 50% of the thermal image are displayed. The temperature range can be adjusted manually or to the lowest and highest temperature in the thermal view automatically. The possible thermal settings are summarized into thermal profiles. By default, there are predefined thermal profiles active. They can be switched with the keyboard. By pressing Enter, the settings can be reached. Under thermal profiles, they can be enabled or disabled. Up to 30 profiles are available and each profile is fully customizable. For each thermal profile, the value range of the parameter can be limited individually. Not every flight controller provides a servo output, so the servo can be directly connected to the IR-Cam. The attitude of the drone is used to adjust the servo tilt, so the hotspot stays always in view. By switching flight modes, the camera can automatically move to a specific angle, for example for acro flying. Let's take a look inside the box of the InEL IR-Cam. First, you get some information, for example how to connect it to your flight controller. Of course, stickers are also a must. Let's take a closer look at the IR-Cam module. It consists of an analog FPV camera and a thermal sensor. Both are protected by an anodized aluminum enclosure. With a width of only 19 mm, it fits into many frames easily, starting at 3 inch. The image is processed by the IR-Cam base in real time. On the PCB are several analog to digital video converters and a powerful FPGA. There are mounting holes for 20 mm and 30.5 mm fastenings. There's also a compact servo motor with metal gear included. It comes with a flexible joint to contribute to a robust system. There are also parts included to customize the length of the servo arm. Alternative camera fixtures are inside too. The FPV camera is changeable. Of course, the necessary cables are present. For setting options, without the radio, the included keyboard can be used. In the small bag are some accessories like screws and dampers. As you can see, there's a lot in the box, which is why it's not just a thermal camera, but a mixed thermal FPV solution. Let's connect it to a flight controller. First, take the 12-pin cable. Please make sure the yellow video cable is on the right side of the IR-Cam module, as it is drilled. Handle with care when plugging and unplugging. Then plug it into the base like this. The OSD keyboard can be plugged in here. Seven wires has to be soldered to the flight controller. The drilled black wire belongs to ground. The red one goes to battery. Up to 6S are supported. For the MSP communication with the flight controller, the blue TX belongs to RX and the green RX to TX of the FC. The yellow wire is the video output. Keep it drilled with ground. The orange wire is for the supply voltage of the FPV camera. It's passed through, so take care of the voltage range. In this case I use the 5V of the flight controller. The second serial interface is optional and has no additional functionality. Only one at a time should be used. Let's connect the FC to the configurator. We recommend using iNav because of the available navigation modes. But Betaflight is also supported. The setup is the same. First, enable MSP on the chosen serial port. 115-200 baud is already correct. Save and reboot. For the lock mechanism of the Servo, set the modes camera control 1, 2 or 3 to the same channel as your flight modes in which the Servo should be movable. In my case, boss hold is on channel 6 in the middle. So I do the same for camera control 1. Save. For the OSD, we recommend to leave the middle and right side empty, as there are the thermal image and values of the parameters. For the usage of the RC stick commands, make sure AETR is used for channel map. Here you can also check if the mixes of your radio work. If you want to use the one-axis gimbal feature, you need camera holders which fits to your frame. You can find chosen ones as STL file on our homepage. Use those designs as a starting point. The servo arm can be customized too. A detailed description can be found in the manual. For example, you can mount the servo on top with double-sided tape. It's simple, but not that durable. I will show you how to mount the IR-Cam with the servo behind. The holder consists of two parts. Insert the servo and add the flexible arm with a long M2 screw. The IR-Cam module is mounted with the threads of the FPV camera. So make sure they are aligned correctly to the holes of the enclosure. Then the M2 8mm screws are used. Do not screw on too tightly. It's also used as rotating point, so the gap is desired. Do the same on the other side. And then mount the long M2 screw. We recommend using Loctite screw lock. The screws could become loose after some time. Then you can check it. Make sure it's easy to move. Shorten the cable to the correct length and solder it to the labeled pads on the IR-Cam base. For the first commissioning, use the servo with an unmounted servo arm. I have connected the keyboard. Enter the settings. Go to the servo settings. Make sure the servo is enabled. During this step, the servo stays at the test position. So at 0%, I mount the servo arm like this. Test if the orientation is correct. Otherwise, the direction can be inverted. Here it moves in the correct direction. Now minimum and maximum position can be set. As it is inverted, maximum can be adjusted at test position 0% and minimum at 100%. The scale is necessary for the automatic attitude adjustment. The locked position is where the servo stays locked. If you want to use a locked camera angle when flying acro or angle, you can set up the servo to only unlock in up to 3 camera control modes. Those are mapped in the Modes tab of Betaflight or INAV. Use the same channel as the flight modes where you want to unlock the servo. In which modes the servo is unlocked has to be set here. I use camera control 1, as said before in the FC setup. Save and exit. For testing, use a thermal profile where the servo is adjustable. How to set up the radio is explained in the next section. By changing the value, it moves. You can also check the automatic angle adjustment. If it's not staying in the same view, adjust the scale for auto mode. To set up the radio, go to the Mixes tab of your model. We use the pre-arm on channel 8 for switching between the thermal profiles and channel 9 and channel 10 for the adjustable parameters. So let's delete one to show you how they can be added. Scroll down to the plus and add a new channel. We take channel 10. Give it a useful name and select the source. To adjust parameters, we prefer analog channels. So let's take the potentiometer on the right side. By moving the turning knob, it is already suggested and can be selected. Make sure the radio transmitter is transmitting the added channels. In some modes, it's limited to 12 or less channels. So go into System and for example to Express LRS. Depending of the packet rate, different modes are available. Check switch mode. You can test whether it works with your configurator in the Receiver tab. For the usage of the RC stick commands, make sure AETR is used for channel map. Now let's check the RC settings of the IR-Cam. Make sure the internal channels profile, left edge and right edge are assigned correctly to your chosen RC channels. Save and exit. Now let's test it. The profile can be changed with the toggle switch. By moving the left turning knob, the transparency is changed. By moving the right turning knob, the temperature threshold is changed, as it is displayed beside the profile name. Alternative, an analog channel can be used to select different thermal profiles. Switch the profile type to range switch. I've set the buttons of the radio to channel 11. Now the profile is selected by the buttons. Make sure the count of the active profiles matches the button count. The range switch is also overruling the OSD keyboard. If you have preferred settings for the FPV camera, you can take usage of the FPV-Cam pass-through. Here, for example, you can change to NTSC. Use the default pull-up resistor. It's only necessary to change when using a different camera. Enter the pass-through and press enter again to open the settings of the FPV camera. Here you can set up different image settings. By default, the video stream is in PAL. Unfortunately, the display cannot handle the change of the video standard without power cycle, so let's switch back to PAL. In comparison to NTSC, PAL has a bit higher resolution at a lower frame rate. After 10 seconds without input, the pass-through is terminated. Due to the mounting, the thermal sensor relating to the FPV camera is shifted. Use the X and Y overlay position to match thermal image with the visible image. If you change the image ratio of the FPV camera, also the scaling must be updated. To do so, take a thermal signature in the distance and start with the top left corner. Adjust the X and Y position. Then use the top right corner to set up the scale in the X-axis. Finally, with the bottom center you can adjust the scale of the Y-axis. You can also flip the thermal image and change the temperature unit to degree Fahrenheit or Kelvin. In the thermal profile selection, you can enable and disable the selected thermal profiles by pressing left or right. Favorites and enabled profiles are sorted displayed. A preview of the current selected profile is shown without UI when you switch between the profiles. Up to 30 profiles can be fully customized. The advanced setup of the thermal profiles is shown later in this video. In the information screen you can see the current firmware version. You can do a firmware update online. A link is in the video description. After changing the settings, make sure to save and exit. Otherwise, the changes are discarded. Now you are ready for your first flight with the InEL IR-Cam. In this part I will show you how you can customize thermal profiles. First we add the servo motor to an existing thermal profile. Connect the RC. Enter. Go to the thermal profile selection. Let's take thermal auto. And now go down to the servo, which is in default condition. Press enter. Now we can choose between different modes. Default takes the last position and keeps it. Adjustable uses the RC channel. The internal left edge and right edge can be used. With the auto mode it takes the RC channel too, but compensates it with the attitude of the drone. We map the servo to the left edge RC channel. Return. In the preview you can see auto, left, the current value and the range of 0 up to 100%. Return. Very important, save and exit, otherwise the changes are discarded. Now you can see the profile thermal auto is active and the servo is adjustable. You can recognize it by the S on the left side in the brackets. Now you can turn the switch on the RC and the camera moves. If the orientation of the drone changes, the servo position is automatically adjusted. The thermal image is a bit off. This is due to the short distance between the camera and the objects. When you fly, the distance is larger and it fits to the real image. If we want to measure the temperature, we recommend a distance of 5 meters. Now let's add another functionality. We want to add transparency. We go into thermal auto again. With IR range, everything over and under the threshold is displayed. There is also the whole range or none possible. You can choose between different positions. You can choose between different color schemes. Now we want to add transparency to our second RC channel. Press enter. It's fixed at 75% now. Let's change the mode to adjustable. We use the channel right edge. I want to adjust it in a range of 25 up to 100%. Return. Return. Save and exit. Now we have the transparency symbol on the right side in the brackets. By moving the knob on the RC, the transparency changes. At a transparency of 100%, the motif of my cup cannot be seen. But when we lower the transparency value, you can see it shining through. So you can fly easily, because every image information you need is visible. You have created your own thermal profile with servo positioning and transparency. Now I want to show you how you can create a thermal profile with manual temperature range. Connect the RC. Go into thermal profile selection. Next. Next. Let's use a default profile. Let's call it InEL FPV. It's our new favorite. Everything over the threshold is shown. It's positioned superimposed in relation to the real image. We take hot yellow, cold red. The threshold type is in percentage. We can use the auto transparency and we want the temperature range to be adjustable. We want to use the left side for the minimum value and the right side for the maximum value. So we use the left channel, then we can select a range. With the RC channel, it's not that precise if we use a large range. So let's take 0 degree up to 50 degrees Celsius. For the threshold, we take a fixed value. Everything about the minimum value should be displayed. So let's take 0.5%. Enter. Now we select the maximum value. We want to change it with the right side. We used a range of 0 to 50 for the minimum temperature, so let's take 5 to 55 degrees Celsius for the maximum temperature. Enter. We keep the servo at default, so it stays at the last used position. Now let's check the preview of our parameters. Transparency is at auto with 75%. The minimum temperature is adjustable with the left channel. The current value is about 30, but the adjustable range starts at 0 and ends at 50 degrees Celsius. Then we have a fixed threshold of 0.5%. So everything over the minimum temperature is displayed. We have the temperature maximum adjustable with the right channel. The range is 5 up to 55 degrees Celsius. Now return. Because it's our favorite, it's positioned after the enabled profiles. Let's enable it too. Return. Save and exit. Switch to our new profile. Adjust the servo before like this. Here we can see our manual mode. We can choose our minimum temperature like this. The color is also adapted. This is very bright. Here you can see the solder iron. But if we go down a little with the maximum temperature, we can also see the temperature of the monitor. That's all you need to know to integrate the InEL IR-Cam into your FPV build. We hope you enjoy exploring. You can start easily, but the customization options are endless. Subscribe this channel to see the latest impressions and get informed about new updates.